In this example, we'll be looking at Rufus and Maria, who are offered different jobs in a new city, and the real estate broker gives them a list of apartments showing them the square footage and the monthly rent. And we want to see if there's a linear correlation between that square footage and the amount of rent that they would have to pay. So we're going to be using Desmos and a linear regression equation to interpret the correlation coefficient. So first thing is you need a Desmos window, and the first thing we need to do is we need to enter this table set of data into the Desmos screen. So opening our Desmos window, first thing is we want to insert a table, and under the X's, we're going to put all of our square feet. So for example, our first square footage is 664, and then our first monthly rent is $995. Go down to the next box. Our next square footage is 735, and then our next monthly rent is 1,045. And don't forget that Desmos does not like when you use commas, so don't use any commas. Go ahead and pause the video, and then you can enter in all the rest of the table data. After you've made your table, something to notice is that you're not going to see your data. Now, if you use the zoom out buttons, so you go, hopefully you can start to see your points. Once you do, you can zoom back in, and then you can see the distribution of your points across the screen there. And if you really want to, you can go into your settings and change your settings to the exact parameters that you want. But zooming in and out, then at least we have a general view of what our different rents and different square footages look like. So now we need to make our linear regression line. So since it's linear, we know we want to use y equals mx plus b, but here we have to do a few things. We have to first show that we want to use the y and the x from the table. So if we look at the table here, we can see that x is really x1 and y is really y1. So when we enter in our equation and we enter in that first y, we want it to say y1. You'll notice that that 1 is a little small number, kind of the opposite of an exponent. It's called a subscript. So to do a subscript, if you hit the 1, 2, 3 number button, and then the button right next to that, it's kind of a little line underneath there, it'll bring you down into the subscript area where you can type a 1. And then you can just use your over keys to get back up into the top there, or click up into the top, and it'll go out of the subscript area. So we want to put the equal sign in, but we don't want to use an equal sign. We want to use one of these. So this is going to tell us approximately. So the way to get to that, if you didn't see that, was go to your 1, 2, 3, come over here. There's some extra options over here. If you're using your keyboard, it's a shift and then right above the 1 key here. And here's that little mark again where you can type that in to use. And then we want to have mx plus b since it's a linear equation. So mx, but remember we want to use x1 from the table. So I'm going to go back and do another subscript, 1, 2, 3 key, and then my subscript key right next to it. Type the 1 in, get out of that subscript area there, and then do my plus b. And now that's going to spit out some data for me. So I can see that in my data here, it's giving me some parameters. It's giving me that b value, so it's telling me my m, it's telling me my b, and then remember r squared and r, we're looking at the r there. That r is our correlation coefficient. Now the question wanted us to write the linear regression equation and determine the correlation coefficient. So here we can see that our m is 0.906 underneath the parameter section. So I'm going to round that to 0.91 and put that in the m for the mx part. And then our b, or our intercept part, is the 403.087. I'm going to round that to 403.1. Put that in there. And then our correlation coefficient is the 0.9607, and that falls underneath the strong positive correlation, meaning that there's a strong positive correlation between the amount of square footage and the monthly rent. Or in other words, as the square footage increases, the monthly rent also increases when you go to buy a house or rent an apartment.